Okay, so Unit 9 is all about these formulas, so you really have to understand what they do and how to use them. You also have to understand vocabulary, so you have to be able to read the question and understand what it's asking. So I've got these formulas on every page, so we can kind of use them to figure out what's what. So section 1 is solving sequences. It says, write the explicit formula for the sequence. Now, in order to write an explicit formula, you have to know what kind of sequence it is. So what we could do is we could try to either calculate the D or the R, because each formula has its own difference between terms. So if I was going to calculate D, what I would do is I would take all of my terms and label them. Let me undo this and make it kind of skinnier so I can have space to write. So this is the first term, second term, third term, fourth term. So if this was a arithmetic sequence, it should have a D. So if I calculate the D is calculated by taking A2 minus A1, which would be 9 take away 3. So that gives me, what, 6? And then if I take the next pair of next door neighbors and do 27 take away 9, you can see that that's not going to give you 6. So that means that this is not an arithmetic sequence. So what we can do instead is we can actually try to calculate R. R is found by taking A2 divided by A1, and then A3 divided by A2, and then A4 divided by A3. Now, no matter which one you type into the calculator, you find that all of these answers are just 3. So that means that this one has to be a geometric sequence. So what else does it say? Oh yeah, so to calculate the, or to write an explicit formula, that's going to be this guy right here. You can see that you need the first term, which we have right here, and we need R, which we also have right here. That's our R value. So all we have to do is plug it into the formula. So AN equals 3 parentheses 3 to the n minus 1. And then that's our final answer. Now problem 2, if you look at problem 2, I'm going to see if it has a common difference. So if this is A1, A2, A3, A4, and A5, I have to be able to subtract every pair of next door neighbors from right to left. So 5 take away 1, 9 take away 5, 13 take away 9, and then 17 take away 13. Every single one of these answers equals 4. So that is a common difference. So that means that this is going to be arithmetic. So to find the explicit formula for an arithmetic sequence, we need to know A1 and D. So I know A1, and this right here was D. So now I can just plug this stuff into my formula. So AN equals the first term plus the common difference, which is 4, n minus 1, and then we always simplify. So we're going to distribute this. So this is plus 4n minus 4 with a 1 here. And then if I combine, I'm going to combine this 1 with the minus 4. So this is going to be 4n minus 3. And then that's my formula. Okay, next. This is what? This is a longer sequence, but that's okay. I'm noticing that the sequence is going down. And from term to term, if I do 7 take away 12, 2 take away 7, negative 3 take away 2, negative 8 take away 3, negative 13 take away 8, or negative 18 take away 13, it looks like the common difference is going to be negative 5. So our A1 term is here. So now I can write my formula because this is an arithmetic sequence. So AN equals the first term plus the common difference. And you don't have to put a plus, a minus 5. You could just write minus 5. So I'm going to go ahead and I'm going to fix that because I don't like double signs like that. So I'm going to put minus 5. That 5 look like a 5 again. And then n minus 1. And then when you distribute, I put that minus in red because remember that minus has to distribute along with the 5. So this is minus 5n plus 5 with a 12 here. And then if I combine my terms, I have 12 and plus 5 is 17. So it's 17 minus 5n. And that's my formula for that arithmetic sequence. Okay, number 4, it says describe the type of sequence. So you just kind of have to find the pattern and what's happening between the numbers. So for example, this right here looks like it's going up 4. This one looks like it's going up 4, plus 4, plus 4. So that makes it arithmetic. And because it's plus 4, that's basically telling us that D is equal to 4. Okay, number 5. Number 5 looks like it's going up 6 here, up 6 there, and up 6 there. So the pattern is up 6. So again, this is arithmetic. Hold on, I screwed up that spelling. Arithmetic. Okay. Number 6. Now we can try, I always try addition first. So this looks like the board stripping. But this one right here looks like it's plus 3. But see right here, this is where it's not going to really work. This is plus 12. We can't have two different numbers across the top like that when we're trying to find our pattern. So the next thing I'm going to do is, since adding isn't the same, I'm going to try multiplying. So this is times 3, this is times 3, and this is times 3. And guys, if you don't know how to find what you're multiplying by, remember what I told you about R in the beginning. R is A2 divided by A1, A3 divided by A2, A4 divided by A3. I did that in some of the first examples, or the first problems. So no matter what pair of next door neighbors you use, as long as you put the right one on top of the left one, for example, 162 divided by 54, that answer is 3. And every single one of these answers is going to end up being 3. Okay? Next one. Now this one is a little trickier because it has decimals, but clearly you can see that you're not adding a consistent number every single time. So chances are this is going to have a common ratio. So we're going to go ahead and we're going to put the 0.4. Let's see what we got here. This is A1, A2, A3, and A4. So if I was going to do this in the calculator, I would have to set up a few fractions with the right number on top, so 0.04 over 0.4. And then I do it again. I check them all because I got to make sure this pattern holds through all the way through the sequence. So this is going to be 0.04. And then the last one is going to be 0.0004 over 0.004. It's always the right one on top of the left one when we check for R. That's how I'm setting up that fraction. So if you type this in the calculator, you end up seeing that the answer is 0.1. And it's true for every single one of these. The answer is just 0.1. So that means this one is a geometric pattern. Okay. Next, it says determine the type of sequence and then state the common difference or the common ratio. So this is kind of like what we just did. You have to try to figure out what the pattern is doing. And I noticed this one starts off with some fractions, but since a lot of people don't like working with fractions, I'm going to start from the ones that aren't fractions. So from here to here, it looks like it's times 3. From here to here, it looks like it's times 3. So I'd have to say that's going to be a geometric function. So this is a geo function, and R is equal to 3. Okay, number 9. Number 9 looks like it's going up by a constant amount. So from here to here, it looks like plus 8, plus 8, plus 8, plus 8. So that one right there, that's going to be arithmetic. And D is equal to 8. Number 10, the numbers are shrinking, so it's not going to be arithmetic because the first one it goes down by 4, and then the second one it goes down by 2. That can't happen on these patterns here. They have to be the same number all the way through. So if I'm confused on how to do these, and you want to check for R, remember you're putting the right one on top of the left one in the form of a fraction. So you go like that. So it's going to be 4 over 8, or 2 over 4, or 1 over 2, or 1/2 over 1. No matter what you find here, you're going to find that these all simplify to 1/2. So that means that this is geometric. and that means that r is equal to 1/2. And then the next one, this one says 1, 4, 7. This one looks like it's going up by +3, +3, +3, and so on. So this is going to be arithmetic. And tick. Sorry, I got sloppy there. B is equal to 3. Okay, next. Now they want us to find actual numbers in the list. Before you use any formulas, you got to figure out what type of sequence it is. So it looks like this one right here, it's shrinking, and it looks like it's going down by 1/2 each time. Again, if you're not sure, you can always use this formula right here. And if that doesn't give you the same number all the way through the pattern, then you use this formula right here. One of them should work. But I'm looking at it, and if I do 1/2, what is that? 1/2 divided by 1. No, not divided by. I'm trying the subtraction first. 1/2 subtract 1, or 0 subtract 1/2, or negative 1/2 subtract 0. Every single one of these gives me a negative 1/2. So that's my D. So now that I have D, and now that I have A1, now I can figure out what A17 is. That means that we're looking for the 17th number in the list. So anytime they give me this little number down here, that's the value of n. So now I have all 3 numbers to plug into the explicit formula. So if I'm going to put A17, it's going to be the first term plus the common difference multiplied by 17 minus 1. And at that point, it's all just calculator work. So if you type all this stuff into the calculator, you end up getting A of 17 is equal to negative 7. And I'm not going to do all the calculator stuff because there's nothing fancy. You type it exactly how the formula looks in the calculator, so that's why I don't have a calculator up here recording as well. Okay, the next one. The next one says they gave us the first term. They want us to find the 15th term, so that's n. So now we have to figure out if this is going to be a common difference or a common ratio. Now this one, just from looking at it, it looks like it's going to be a common ratio, so I'm going to start with r. So the pattern for r is you take 8/3 divided by 4. You're going to take 16/9 divided by 8/3. And the reason I'm doing this in parentheses is because when you type it in the calculator, the parentheses need to be there. Otherwise, it doesn't know how to, oops, what am I doing? It doesn't know how to calculate it in calculator. It gets really confused. So I'm going to do 32 over 27 fraction over 16 over 9. And then finally 64 over 81 divided by 32 over 27. So if I put that in parentheses, when you guys do this in your calculator is going to tell you that every single one of these is going to equal to 2/3. And then that's the value of r. So now to find the 17th number, we can go into our formula, or not the 17th, the 15th number. So the 15th number is going to be the first number, which is 4, multiplied by r, which is 2/3. And then this is going to be to the 15 take away 1. When you put this into the calculator is going to spit out A15 equals 0.014. And then if you look at the test and the test has a fraction, you just hit the FD button and it'll change it to a fraction for you. Okay, number 14. Number 14, you can tell just based on the signs, this is minus, this is plus, this is minus, this is plus. Anytime you have alternating signs like that, usually means it's going to be geometric. So the geometric function here, it looks like r is going to equal -2. And again, you can set them all up. So 22 over minus 11, or 44 over 22 minus 44, or 88 over minus 44. Every single one of those is going to get you equal to -2. The first term is there, and we want to find the 13th term. So it's going to be A13 equals the first term, -11, times r, so negative 2, and then 13 minus 1. Type that in the calculator, and you end up with the 13th term of this pattern. It's going to be negative 45,056. That's my final answer. Okay, now we have to get into recursive formulas. Now, the bad thing about the recursive formula is there's no shortcut. You have to use the formula in order to find the next number. So the thing you have to understand about a recursive formula is it always uses the previous answer. So let me start off with the first one. So the first one says A1 is equal to 1. Now, we never need a formula for the first one because part of a recursive formula is to always tell you where to start. So we know that A1 is equal to 1. So now if I want to do A2 is going to be 4 times something minus 2. And that something, what you have to understand about the formula and the notation, is this guy right here means the previous number. So the previous number is 1. So now if I work this out, in the calculator, I end up getting that the answer is 2. So there's the first one, there's the second one, and now to find the third one is going to be the same pattern, 4 parentheses minus 2. And just remember, again, the number that goes next to the 4 is the previous answer. So the previous answer is 2, so I got to stick a 2 in here. So if I do this in the calculator, this right here ends up giving me 6. So the numbers are 1, 2, and 6. Okay, next. So the next one says the first number is 5. The second number is found by taking 2 times something minus 1. And remember how I said this? It's going to be this. That's the previous number. So the previous number in here is 5. I'll put a 5 in here. When I work that out into the calculator, it's going to tell me that the answer is, what's that, 9? Then I go back and do the pattern one more time. So A3 equals 2 times the previous answer. The previous answer was 9. So I put in a 9 there. So I end up with, what is that, 17? So the first 3 numbers in the pattern are 5, 9, and 17. Oh. Okay, here's another one right here. So on, let me see, what do? We did 15 and 16 already. So here's 17 and 18. So on 17 and 18, it says, given the formula and the first term, write an explicit formula for the nth term. So the fact that this has a 3 being multiplied out in the front tells us a lot about what formula we're going to use. Anytime we have a number out in the front of the previous term being multiplied, that's basically your R. So now to write the explicit formula for a geometric series or a geometric sequence is going to be A sub n equals the first term. The first term is right here, so I'm going to put a 3 here. And then R goes on the inside of the parentheses, and we've already established that R is that number there. And then we just have to stick n minus 1 up in the exponent position. So that's my explicit formula. There's no work to do when we simplify it. Okay, next, it says, write a recursive rule for the geometric sequence. Now, the fact that they tell us geometric tells us a lot. So we're going to start off with a formula that looks like this. We have to write a formula that uses the previous term, and n minus 1 is the previous term. Now, because it's geometric means you have to take R and multiply it right there. So now, we should be able to write our formula. So if we write the formula for this, it's going to be an equals R is equal to 2. So 2 times an minus 1. And then we have to tell everyone where to start from. So a1 is equal to 5. So that's our formula. The next one says, write a recursive rule for the arithmetic sequence. So they tell us it's arithmetic. So the pattern for arithmetic looks like this. It's the previous number added to the common difference. So they tell us the first number. They tell us the common difference, so we can go ahead and set up our formula. So it's an equals an minus 1. The common difference is minus 3. and then I put a comma, and then I tell everyone start at 7. So there's my formula. Okay, the next one says write the first 3 terms of the sequence defined by this pattern. So this is another one where you just have to not take any shortcuts. So the first number is 1. The second number is found by taking 2 times the previous number plus 3. Remember how we said earlier, anytime you say an minus 1, that means the previous number. So the previous number has to be, oh, I put the wrong number in. Good thing I did that. So I got to put a 2 right here. Again, 2. So that's going to be a 2 on the inside. So I put a 2 on the inside here. And when I work that out on this question, you end up with 7. Then to find the next number in the pattern, it's going to be 2 times the previous answer plus 3. So I stick in the 7, and then what is that? 14 plus 3, 17. So the first 3 numbers of this pattern are 2, 7, 17. Okay, next one. The next one says first number is 3. A1 equals 3. So A2 is found by taking the previous number and subtracting 5. So I'm going to take the 3 and minus 5, so that's minus 2. And then I got A3 is equal to the previous number minus 5. So I stick in negative 2, and that's going to give me negative 7. So this pattern starts with 3, goes to negative 2, and then negative 7. And then one more here. What else do we have? Let's see. Yeah, so this one starts off at 1. Why do I keep saying that? This one starts off at 4. So I'm starting A1 at 4. And then the pattern says the next number is found by taking negative 2, multiplying it by the previous number, and then subtracting 1. So on this question, we're actually going to plug in the 4. So I'll do that one in blue. And when we work out that problem right there, that gives us minus 9. Then we go back into A3. A3 is negative 2 parentheses minus 1. And we put in the previous answer, which was minus 9. And when you work that out, that ends up giving you, let me see, positive 18 take away 1 is 17. So the 3 numbers for problem number 24 are 4, negative 9, and 17. Okay, next. This one's a word problem. It says Hector started to train for a triathlon. The table shows the number of miles Hector ran during each of the first 3 weeks after he began training. Write a recursive formula and the explicit formula for the set of data. So when we're looking at this, we have to figure out these top ones. This is like A1, A2, and A3. But the bottom ones is where the pattern actually is. So to go from 10, what is he doing? Oh yeah, this is 10 miles to 15 miles. That's plus 5. And from 15 miles to 20 miles, that's another plus 5. So every week it looks like he's going up by plus 5. So right away, that tells us that this pattern is arithmetic. So if we have an arithmetic pattern, that means that D is equal to 5. And then to do anything, we always have to know the first term. So there's the first term. So now it says write the recursive formula. So the recursive formula follows this pattern here. It's A1 equals A n minus 1. That means the previous number. And then plus D. And then we have to say what A1 equals. So if I just fill in the numbers from the table over here that I have AN equals the previous number. And the common difference is 5. And the first week he started at 10. There's my recursive formula. And then my explicit formula, that's the other formula where it's going to be the first term plus the common difference, and then n minus 1. So we have to plug in this number here and this number here. So A1 is 10. The common difference was 5. And then we just distribute. I'm not going to do that. I wanted to put plus 5 in, and I knew when I put the other 5 over there, I was going to want to put plus 5. That's actually a minus 5 from positive 5 times negative 1. I have to combine the 10 and the minus 5. 10 and minus 5 gives us 5, so there's going to be 5n plus 5 equals an. So there's my explicit formula. Okay, now this one is now solving the series. Remember that the series is equal to the sum. And anytime we do sum formulas, they have to have the formula that starts with an S. So it says find the sum of the first 10 terms. Now this part right here is important because they're telling us that n is equal to 10. Showing the work and the formula used, do not list all the terms and then add. Okay, so the first thing we have to do is we have to figure out which type of sequence it is, which type of pattern, so that way we can use either the arithmetic formula or the geometric formula. So on number 26, it looks like this one is going up by times 3 each time. And I'm not going to write it across the whole pattern. You can see that it's times 3 every time. So that tells us that r is equal to 3. We know that a1, the first term, is equal to 2. And we know because we're trying to find the sum of the first 10, n equals 10. So we're going to use this formula in the geometric sum formula. So the formula goes like this. The sum of the first 10 is equal to the first number. The first number was 2. And then 1 minus the r. R was 3. And then this is going to be to the 10th power. And the formula n is the same number in both times. And then you have 1 minus 3. You type that into the calculator, and you're going to end up with 59,048. That's our final answer. Okay, next. The next number, again, we already know on all of these, they want us to add up the first 10 terms, so we automatically know that n is equal to 10. Now this pattern looks like it's going down, and it looks like it's going down by 5, so this right here is going to be negative 5 for D. And then again, we always know we need to use that first number in all of our formulas, so the first number is 12. So this right here, this is an arithmetic pattern. When we do the arithmetic sum, we're going to find, so let me write down the formula because this is important right here. So to find the sum of the first n numbers, you have to take n, so that would be 10 divided by 2, but you would have to take a1 and add that to an. Now the problem with that is they hardly ever give us that number. So this one right here, this is 1, 2, 4, 5, 6, 7. They only go up to 7. So we have to find the 10th number first. So that means that we have to use the other formula. So an equals, not a10 equals the first number, which was 12, plus the common difference. The common difference was minus 5. And we're going to do 10 take away 1. Now when you type that in the calculator, you're going to get that the 10th number in the pattern is negative 33. Now that's important because that's the number we have to use in this spot. So now I can actually do the formula. So the formula for the sum of the first 10 numbers is going to be 10 divided by 2. It's going to be the first number. The first number was 12. And then we have to add the 10th number, which we found was negative 33. You type all that into the calculator, and you find that the sum of the first 10 numbers is going to equal negative 105. Okay, number 28. Number 28 says 3, 9, 20. So this one you can tell is going to be times 3. So that means this is r is equal to 3. N is always equal to 10 because that was in the instructions in the front of all the questions. And then we know that a1 is equal to 3. Now the cool thing about this is anytime we're doing these geometric patterns, we don't have to do 2 steps because we don't need the 10th number in the list. All we need to do is calculate the sum of the first 10 is equal to the first number, which is 3, and then 1 minus r to the 10th power, and then 1 minus R. Type all that stuff into the calculator and you end up with, let me double check this in my calculator. So I'm going to put a fraction 3 minus, oh, hang on a second, it's not 3 minus, it's 3 parentheses 1 minus 3 to the 10th. And then down at the bottom, I'm going to put 1 minus 3. So this answer right here, S of 10, gives us 88,572. Okay. Now, last one of the section is a word problem. The word problem says a patient takes 400 milligrams of a supplement each day. Approximately 1/3 of the supplement remains in the body at the end of the day. It says, is this situation arithmetic or geometric? Now this one right here, you're not subtracting 3/3 every time. You're going to have 1/3 left. So however much you have, it's going to be 1/3 times that number. So that automatically makes it a geometric sequence. Okay, so then it says how much of the supplement remains in the patient's body immediately after the 21st dose. So in order to calculate this, we need to figure out, what do we know? Let's read it again. Patient takes 400 milligrams supplement each day. So in day one, they have 400 milligrams inside their body. We know because it's geometric, it's going to go down by 1/3. So R is going to equal 1/3. And we want to find how much is left in his body on the 21st day. So N equals 21. So it looks like the person is only taking the 400 milligram dose once, and then each day there's a third left. So here's what's going to happen. We don't have to find the sum of how much dosage he has in his body, because we're not adding to it. So all we're going to do is find the 21st number in the list. So in a geometric sequence, we're going to find, what are we going to find? How much supplement remains in the patient's body? Patient takes 400. I'm just reading this to make sure I have this right. Yeah, so we need to know how much is in his body on the 21st day. Wait a second. I'm reading this wrong. Okay. Oh, okay. So this dude is taking a 400 milligram dose each day, but then of that 400, there's still a third left. So he's got the third, and then he's going to add another 400 to it. So this one actually is a sum. So we're going to find how much is in his body after the 21st dose. So the word dose is important because it's basically 21 times that he's taken the pill. So we're going to find the sum of the 21st dose. Yeah, that makes more sense. If they would have just said he took the pill one time and they want to know how much is left in his body after 21 days, then we would use the other formula where we would find the 21st number in the list. Okay, so we're going to do the first dose, 1 minus R, which R is 1/3. And then this is going to be 21, and then 1 minus 1/3 again down at the bottom. So we type this into the calculator, and when you get it into the calculator, it ends up being 500, oops, not 5.9. It's going to equal 599.999, pretty much forever. So I'll just round that to about 600 milligrams. So after 21 pills, he's going to have 600 milligrams in his body because the 1/3 of the previous days, the 1/3 amount keeps getting added to the new amount that he puts into his body. Okay, let's see what we have now. It looks like now we have some review. So on the review stuff, we got to make sure that we remember how to do these problems that have the bases. So the whole thing about this is we want to try to make these match. We want to try to make 27 turn into a 9. But 9 to the first is 9, and 9 squared is 81, so we've already passed it. So that means that we have to try to change 9. 9 can be rewritten as 3 squared, And because that already had some stuff in there, we're just going to put it back into parentheses. Then on the other side, 27 can be rewritten as 3 to the third. And because that had stuff up there, we're going to put that stuff back into parentheses. Now, because these problems can be rewritten both with base 3, we can cross them out. So this problem over here now becomes 2x equals 3x minus 6. Subtract 3x to get x on one side. And then divide by -1. So x equals 6. Okay, now, problem 31 looks like we cannot change a 10 into a 7, and 7 is prime, so 7 can't be rewritten either. So in that case, if you can't change the bases so they match, you just have to take the ln of both sides. That releases the exponent out to the front, so you're going to have x minus 1 times the ln of 7 equals the ln of 10. And then what you're going to do is you're going to try to get the parentheses by itself by dividing by the ln of 7. So now x minus 1 is all by itself. And now we just have to add 1 to the other side. So those cross out. So we type this in the calculator, and chances are it's going to be a decimal. Looks like the decimal is about 2.183. And I rounded, so I probably should have put the little squiggly lines. Okay, last one says simplify completely. Simplify completely means factor and cancel. So the first one on top, that's an ABC problem, so you should be able to do that in your calculator using the solver. When you put it into the solver, I think it's going to get you +6 and -5, so that means in here it's got to be -6 and +5. And then down at the bottom, that has a GCF. The GCF looks like it's going to be 2. So I take out the 2 and then write x plus 5. And then our restrictions are going to be -5 only. We don't care about the 2 because the 2 doesn't have an x on it. All we care about are the x's. And then we're going to take our red pen and cross out the matchings. So the matching parentheses are x plus 5. So our final answer is going to be x minus 6 all over 2. And you can leave that in parentheses. Okay, so that's it for the review. I know that was a lot, but again, it's a lot of calculator work, and you have to understand what the formulas do and what all the parts of the formulas mean. You have to know how to calculate R, you have to know how to calculate D, and you just have to know how to type the stuff in. So hopefully this review helps you.